Hi everyone, thank you for joining. So in this video we're going to solve another interesting integer equation. So given that x, y and z are positive integers, we will try to find the values of x, y and z which satisfy this equation. Right? If you'd like to pause the video and try it yourself first, then we could go over it together. Okay, so one way to solve this video, if we simply use substitution, if we let a to be x minus 1, b is y minus 1, and c is z minus 1. So the motivation for this substitution is that we want to get rid of this 2 somehow, right? Okay, so if we plug that in, so what will we have? We will have, instead of xy, we will have a plus 1 into b plus 1, and then plus b plus 1, c plus 1, plus c plus 1, a plus 1, minus a plus 1, b plus 1, c plus 1, and that's equal to 2, right? Okay, so it's very easy to make a mistake, so let's go step by step. First of all, let's expand that. We will have ab plus a plus b plus 1, and that is bc plus b plus c plus 1, that is plus ac plus a plus c plus 1, and now let's break that into 2, so we will have minus ab plus a plus b plus 1 into c plus 1, which is equal to 2, okay, and that will give us minus abc plus ab plus ac plus a plus bc plus b plus c plus 1. That's equal to 2. Okay, right, and because it's minus, so let's make all of them minus. So it starts here, minus, that will be minus, minus, all minus here, right? Okay, so let's start cancelling then. Now we'll start with plus AB goes with minus AB, AC goes with AC, BC goes with BC, A goes with A, B goes with B, and we have C here, that goes with that. Let's cancel this one with that. Okay, and let's write down the remaining terms. B plus 1 plus A plus C plus 1 minus ABC is equal to 2, right? So in other words, A plus B plus C minus ABC. So in other words, we have A plus B plus C is equal to ABC, right? Now, given that ABC is not equal to 0, well, first assume that it is 0. If ABC is equal to 0, that implies from the definition, if ABC is 0, one of the possibilities are 0, 0, 0. And that if that's the case, that means x, y, and z would have to be 1, 1, 1, right? And let's check whether x, y, z, 1, 1, 1 satisfies this equation. Well, indeed it does, isn't it? Because you have 1, 1, 1, minus 1. So 2 is equal to 2. Okay, so that's one solution. Now, if ABC is not equal to 0, then we can divide both sides by ABC. So we have 1 over BC plus 1 over AC plus 1 over AB is equal to 1, right? So we have an equation in the form of 1 over K plus 1 over L plus 1 over M is equal to 1, where K, L, and M are positive integers. Yeah. Okay, so let's use our usual inequality method. That means we can order these numbers because they are positive integers. So K is less than or equal to L, less than or equal to M, let's say. That means we will have 1 over K. If we replace L by K, that will equal to 3 over K, which would be not equal to 1 because K is less than L and M. That would be greater than or equal to 1. So let's write it as 3 over K is greater than or equal to 3 over 3, right? that the possible values for k is k must belong to 1, 2, and 3, right? But one thing to notice here, that if k is 1, you already have 1 over 1 here, and since these quantities are greater than 1, it will never equal 1. So k cannot be 1. Can k be 2? Yes. Can it be 3? Yes. Okay, so let's test these values then. So for k is equal to 2, 1 over L plus 1 over M is equal to 1 over 2. Yep, if you take 1 over k on the other side. So that means we will have 1 over L is equal to 1 over 2 minus 1 over M, which is equal to M minus 2 over 2M. So L is equal to 2M over M minus 2, which can also be written as 4 over M minus 2, isn't it? Okay, so we have L is equal to 2 plus 4 over M minus 2. Now we know L is a positive integer. We're only interested in the values of for which this is belong to integers. So possibilities of M, well, can M be 1? Well, M can be 1 because M is a positive integer. But then we have 1 minus 2, which is minus 1. And then 4 over minus 1, that's minus 4. 2 minus 4, that makes L negative. So we're not going to consider this. So we'll only count M is 3. Right, M is 4, and M is equal to 6. Now, using these values, we could work out what what L is, right? K, M, L, right? So K is 2. When M is 3, we're going to have 6, isn't it? Because if M is 3, L will be 6. Similarly, the next result will be 2, 4, 4. And if you notice that when M is equal to 6, we're going to get 2, 6, and L will be 3, and so on. So what we're getting is some sort of permutation of the solutions. But we know that using the symmetry, permutations of or rearrangements of every solution is a solution itself. In other words, we could have 3, 2, 6, or 2, 6, 3, and so on, just exploiting the symmetry, right? So I'm just going to leave that one out and these ones out for now, right? And now the last case, that when k is equal to 3, we will have simply, that's quite straightforward, because if you look at the equation here, if k is equal to 3, obviously L and M are also equal to 3, because you have 1 over 3 plus 1 over 3 plus 1 over 3, so you have 3, 3, 3 as a solution, as k, L, and M, right? Okay, now let's write these solutions explicitly. So we have 2, 3, 6, 2, 4, 4, and 3, 3, 3. Yeah. Okay, so now the question is, which one of these solutions, or which ones, are valid? So let's think about it. Now, what we had, remember these are the solutions to KLM, and we defined KLM as in here, we defined K to be BC. So let's write it down. In other words, we have here, what we have is we have BC, and I think L was AC, and then AB, right? Okay, so we know that K, L, M are positive integers. Similarly, ABC are positive integers. That means BC, AC, AB are also positive integers. So let's have a look at it. For example, if we look at K times L times M for this bracket here, we're going to have 3 cubed, which is equal to 27. Well, what is K times L times M? Well, that's BC times AC times AB. In other words, we have A squared, B squared, C squared. That's equal to 27. ABC squared is equal to 27. This doesn't work because if ABC are positive integers, we need 27. We need a number that is a perfect square, right? So this solution doesn't work. Now the next, we check let's say this bracket here. So we have k times L times M is equal to 2 times 4 times 4, which is equal to 32. But again, that will equal to ABC squared, right? And 32 is not a perfect square, so that doesn't work either. Now, let's check the next one. KLM is equal to 2 times 3 times 6, which is equal to 36, which is 6 squared, which is equal to ABC squared, okay? So this one works, right? And we had one more solution in the beginning, 0, 0, 0, or 1, 1, 1, if you remember, right? So the solution we had in the beginning was, the very first solution was 1, 1, 1. So if you go back to it, so 1, 1, 1, well, it's just 1 times 1 times 1. It's a solution. So I'll write here 1, 1, 1. It's certainly a square number, right? Okay. Now, of course, these are solutions for KLM. Not 1, 1, 1 though. So this is a solution for KLM. So let's have a look at it, and let's find it. What is it for X, Y, and Z, right? So what we have now is that we have K is equal to 2, L is equal to 3, and M is equal to 6. Just writing this there, right? Okay. And in other words, we have BC is equal to 2, AC is equal to 3, AB is equal to 6, right? So let's solve it. If AB is equal to 6, well, why don't we eliminate C from here? So we have B over A is equal to 2 over 3. That implies 3B is equal to 2A. And combine it with that, that means we have 3B squared is equal to 2AB, multiplying both sides by B. That means 3B squared is equal to 2 times 6, because AB here is 2 times 6, isn't it? So B squared is equal to 12 over 3, which is 4, so B is equal to 2. Now, if B is equal to 2, that means A is equal to 3, right? And if A is equal to 3, from here, we have C is equal to 1, right? So we found ABC, so 3, 2, 1. That's ABC, but we want it in X, Y, Z. So remember, we said the definition of ABC was X minus 1, yep, Y minus 1, and so on. So what we're saying basically is we're saying X minus 1 is equal to 3, Y minus 1 is equal to 2, Z minus 1 is equal to 1. So in X, Y, Z, we have 4, 3, 2 is the solution, right? Okay. So just to sum it up, so the solutions we have are 1, 1, 1, and 4, 3, 2. And of course, considering this symmetry, all the permutation of these solutions, well, obvious in this case, but all the permutations of the solution is a solution itself, right? So 4, 3, 2, 2, 3, 4, and so on. Yeah. Okay. Well, I think this was an interesting question. So I hope you found it interesting and you enjoyed it. Thank you so much for joining, and I look forward to seeing you in my future videos. Thank you.